Okay, this is lesson 14, factoring special cases and non-factorable trinomials. Students will factor special cases and identify non-factorable trinomials. So we're in the concept of factoring, which we should already know from Algebra 1, but factoring is the opposite of multiplying. We're breaking things apart because someone multiplied it ahead of us and now we were undoing what they did, okay? Sometimes there are special examples that should go quickly. And we talked about difference of squares a couple weeks ago, but we're going to just officially talk about it one more time. So we could if we recognize the pattern or recognize what it's supposed to look like, we could do work more quickly, right? Just like in real life, if you see something, you could more quickly get the job done, okay? So football players, got a question for you. If sometimes, let's say you're doing a play, let's say coach is like, do this play, and then you're out on the field and you got the ball and you notice this big hole and you're like, and you and your team take advantage of this opportunity because it's like, well, there's already a hole to get past the other team, so I'm going to run the ball. Is that a good idea?
No.
Yes or no? And it leads to a touchdown. Is it a good idea? No, but if you get the goal, or if you get a field goal touchdown, right?
You still get yelled at.
But you took an opportunity that was there, right? Because you saw something. Does that make sense? Okay. I won't yell at you. I won't yell at you, okay? I won't be like that. But sometimes you see patterns in life, you're like, oh, that's the example. Or sometimes people see, like, people who follow the stock market or mutual funds or the economy, and they're like, oh, look, there's this pattern is happening within this industry, and so they know what to do to make money. They're like, oh, this is the pattern's happening, therefore I'm going to do this, whatever that is, buy the stock or sell the stock. Okay, same thing here. We want to recognize patterns so that our lives are easier. All right, and hopefully you don't screw up so you don't get yelled at, okay? Here we go. These are the steps for today. Identify the special case. There's two kinds. There's perfect squares and difference of squares. So you already know difference of squares. You should know both of them, but okay. We factor it. And then sometimes you can't break it apart. Sometimes we're like, oh, we try to do an Xbox, or we try to see if there's a special case and there isn't. So, okay, here we go. Numbers 1 and 2. Okay. Numbers 1 and 2. We got 9n squared minus 30n plus 25. Now this problem, I'm noticing something special. The first term and the last term are perfect squares, right? You all see that? The middle term is negative 30n. So we need to check to see if this is a perfect square trinomial. The way you check is you take the square root of 9n squared, which is 3n, okay, and the square root of 25, which is 5, right? Or it could be negative 5. I'm going to say it's negative 5 because it is, this middle term is negative, okay? And we're going to multiply that. And it's going to be negative 15n, right? I know that a perfect square trinomial from Algebra 1 should have this form, a squared minus 2ab plus b squared. That means this middle term needs to be, sorry, it's negative 2ab. This middle term needs to be twice the square root of the first and the last term. So the first and last term, if I multiply it, is negative 15n, but I have to multiply that by 2, so that's negative 30n, right? We're going to multiply this by 2, which is our middle term. Hopefully I'm not confusing anyone right now. So this is stuff you could do on the side, or you could think about this in your head. But since I know this is a perfect square trinomial, I'm going to take my original problem, and I'm going to just factor it knowing it's a perfect square trinomial. So all I'd have to do, once I recognize that's a perfect square trinomial, make two parentheses, take the square root of the first term, which is 3n, write it here and here. Take the square root of the last term, which is 25, or square root of 25 is positive or negative 5, but in this case it's negative because my middle term is negative. And that's it. That's how you do number 1. Okay? Questions on number 1? On number 2, I'm noticing this is two perfect squares with a negative sign in the middle. So, square root of 25x squared is 5x. Square root of 16 is 4. Give me a moment here. So, we got 25x squared. Square root of 25x squared is 5x. We're going to write this here and here. Square root of 16 is 4. Since there are only two terms with just a negative sign in the middle, I know I could use this formula. We're just going to put a plus sign here and a minus sign here, and then you're done. Right? Because this is the pattern. Raise your hand if you remember this from last week. We worked on this. You should all remember this from last week for number 2. Okay, if you don't, that's the special case, okay? Could we have done Xbox on both of these? Yeah, we could have. Which way is faster? Special case or Xbox? Special case. Okay, so turn your neighbor. Okay, I'll start you off. Is there a GCF here? Think about what we did yesterday. Is there a GCF to factor? No. There is no GCF. Could I do Xbox? Yep, you could. But before we do Xbox now, let's just to make sure, can we go faster by asking ourselves, is the first term a perfect square?
Yes.
Good. Is the last term a perfect square?
Yes.
Good. What's the square root of the first term?
2.
2 what? 2x, okay. What's the square root of the last term? 1 or negative 1. I'm going to say it's negative 1 because this middle term's negative. So let's focus on that. So what's 2x times negative 1? 2x times negative 1 is negative 2x. Okay, and then we multiply that by 2. What's negative 2x times 2? Is negative 4x my middle term? It is. So since I know that's the case, I'm just going to move quickly. What's the square root of the first term again? We said it was 2x. We're doing this together, by the way. So we're putting 2x and 2x here. Square root of the last term was negative 1. We're done. Did you all see that? Somebody giving me that face of like, you disagree. Does this make sense? Another way you could write the answer is this. 2x minus 1 squared. Y'all get that? Okay. Which was faster, using Xbox or using the shortcut? Okay. Yes, sir?
How come the square root of the positive 1 is negative 1?
Because what's the square root of any positive number? It's the positive number and the negative root. So, square root of 4 is 2, but it's also negative 2, because negative 2 times negative 2 is 4. Why did we pick negative 1? It's because the middle term was negative. You see?
Yeah.
What if this middle term was positive 4x? We would have picked positive 1 as the square root. Okay? That's a good question. Okay, so, knowing that, look at number 4. You can work with your neighbor, deciding, is this a perfect square? If it is, I want you to use our little system we got. (5n) minus 4 times 5n minus 4, or 5n minus 4 squared. That's it. Okay. When I do this problem, I think about the square root stuff in my head, and I think, okay, what's the square root of 25n? 5n. Square root of 16? It's got to be a negative 4 in this case. 5 times negative 4 is negative 20n. Times 2 is negative 40n. Oh, it's a perfect square. And I think about that quick, and then I just write the answer like this. Right? Can you still do Xbox again?
Yes.
Yes. Who doesn't believe we can't do Xbox? Okay, good. Y'all believe it. That's what I like to hear. Okay, number 5. We've done these kinds of problems. Turn to your neighbor, tell him, is this a perfect square trinomial, or is this a difference of squares? Okay. I'll start you off on this one. This is difference of squares. I know this because the first term is a perfect square. What's the square root of 81n squared, everyone? 9n. What's the square root of 121? What's the sign in the middle? Negative, right? So if that's the case, all I got to do is set 2 parentheses up. Square root of the first term is 9n. Square root of the second term is 11. Then we got a plus and a minus. We're done. That's how you do number 5. We did that together, right? Good. Now do number 6 on your own. Ready, set, go. So number 6, we got, what's the square root of 169? 13 square root of b squared? B. Okay, so we got 13b, 13b. I know that these are both perfect squares. What's the square root of 196? 14. Then you put a plus and then a minus sign. Can we put 13b minus 14 squared? No. Can we do 13b plus 14 squared? No, it's got to have both, right? Plus and minus. Okay? BT dubs, look up here. That's by the way, but like cool because I'm cool like that. Like this video if you think I'm cool. I know. So, 12 squared. We all know 12 squared. You better know 12 squared. What is it? 144. You should write these down, please. 13 squared. 169. 14 squared. 15 squared. 225. 16 squared. 256. Okay. I would suggest you learning these up to 25 or getting familiar with them. Okay? Just because the reason why is not to keep you busy is because if you're familiar with something, you're going to work more quickly. Just like this whole lesson is about familiarity. We're like, these are perfect squares. These are difference of squares. If you're familiar with something and you see an opportunity, wouldn't it be better to notice the opportunities and make your life faster? Right? So we prepare ahead so we're ready for it. Alright, that concludes the lesson.